Discovered in 2004, asteroid 99,942 Apophis quickly garnered attention as one of the most hazardous asteroids potentially capable of colliding with Earth. Named after the ancient Egyptian god of chaos and darkness, Apophis measures about 340 meters (1,100 feet) across, which is comparable to the length of 3 UK football fields. Early calculations indicated a significant threat, predicting that Apophis would come dangerously close to Earth in 2029, causing concern among astronomers and the public. When Apophis was first discovered, scientists used early orbital data to assess the probability of collision. Initial predictions estimated a 2.7% chance of impact with Earth in 2029, which caused significant alarm. This was the first time an asteroid had reached level 4 on the Torino scale of impact hazard, a system used to assess the risks of collision with Earth. The asteroid was discovered on June 19, 2004 by astronomers Roy Tucker, David Thalin, and Fabrizio Bernardi at the Kitt Peak Observatory in Arizona, USA. Initially designated 2004 MN4, it was later renamed Apophis after the god of chaos and destruction in ancient Egyptian mythology. This choice of name underscores the asteroid's potential as a destructive force. Apophis follows an elliptical orbit around the Sun, approaching Earth approximately every 7 years. Its orbit passes between the orbits of Earth and Venus, making it a classic example of an Apollo-class asteroid. These asteroids are characterized by their Earth-crossing orbits, making them potentially hazardous. Since its discovery, Apophis has been the subject of intense observation using various methods. Astronomers have employed ground-based telescopes, radar systems, and spacecraft to gather data about its orbit and physical characteristics. Radar observations made with the Arecibo Observatory in Puerto Rico have been crucial in refining Apophis' orbital parameters. As astronomers tracked Apophis, they refined their understanding of its orbit. These observations show that the risk of collision in 2029 was minimal. However, close approaches in 2036 and potentially in 2068 still raised concerns. It wasn't until March 2021, when Apophis made a distant flyby of Earth, that astronomers could use powerful radar observations to achieve extreme precision in mapping its orbit. These efforts allowed scientists to confidently rule out any risk of collision in 2068 and for many years beyond. Despite the lack of immediate threat, Apophis remains a subject of intense interest. On Friday, April 13, 2029, Apophis will pass closer to Earth than any object of its size in recorded history within 32,000 kilometers, 19,800 miles of Earth's surface. This distance is closer than some geostationary satellites. Observers in Asia, Africa, and parts of Europe will be able to see this event with the naked eye, marking a historic moment in astronomy. Apophis has an elongated shape and rotates around its axis approximately once every 30 hours. Its surface is composed of a mix of nickel, iron, and silicate minerals. These characteristics help scientists understand the composition and behavior of asteroids like Apophis and develop strategies to mitigate potential threats. The fascination with Apophis extends beyond its close approach. Collision simulations provide a vivid picture of the asteroid's destructive power. If Apophis were to collide with a major city like New York, the resulting crater would be approximately 3.6 kilometers in diameter. The explosion, equivalent to 256 megatons of TNT, would instantly vaporize around 12,487 people, exceeding the energy of all nuclear explosions ever conducted on Earth. When Apophis passes by Earth in 2029, the planet's gravitational pull will significantly alter its orbit. This interaction could amplify uncertainties about its future trajectory, necessitating continued observation. Astronomers will use data from this flyby to refine their models and improve predictions. Rapid technological advancements, including space missions to deflect potentially hazardous asteroids, highlight humanity's growing ability to mitigate cosmic threats. Asteroids like Apophis play a crucial role in our understanding of the solar system. Studying their trajectories and compositions helps scientists uncover the history of planetary formation and the dynamic processes governing cosmic objects. Public interest in Apophis is fueled not only by its potential threat, but also by the awe-inspiring spectacle it offers. As we anticipate the close approach of Apophis in 2029, we are reminded of the dynamic and ever-changing nature of our universe. While the immediate threat has been averted, ongoing vigilance and technological advancements are essential to ensuring the safety of our planet. This event provides a unique opportunity for education and public engagement in astronomy. Feel free to share your thoughts on these asteroids. How important do you think such research is for the future of humanity? Share your views in the comments, and don't forget to subscribe to our channel to stay updated on the latest news and discoveries in the world of astronomy. For comparison, let's consider asteroid 101955 Bennu, which, like Apophis, is classified as a potentially hazardous near-Earth object. Discovered in 1999, Bennu has a diameter of about 500 meters, which is slightly larger than Apophis. It also attracts significant interest from astronomers and planetary scientists due to its potential threat and unique characteristics. Bennu was discovered on September 11, 1999, as part of the Lincoln Near-Earth Asteroid Research LI-NEAR project and has been under close observation ever since. Unlike Apophis, Bennu's orbit also intersects with Earth's orbit, making it a potentially dangerous object. Estimates suggest that the probability of Bennu colliding with Earth between 2,175 and 2,199 is approximately 1 in 2,700. One of the significant steps in studying Bennu was NASA's OSIRIS-REx mission origins, spectral interpretation, resource identification, security, regolith explorer. Launched in September 2016, this spacecraft successfully reached the asteroid in December 2018 and conducted a detailed study of its surface and structure. In October 2020, OSIRIS-REx collected samples of regolith from Bennu's surface and will return them to Earth in 2023. This event will mark an important milestone in asteroid research and help scientists understand not only Bennu's composition, but also the general processes occurring in near-Earth objects. Bennu has a similar elliptical orbit around the Sun, bringing it into regular close approaches to Earth. Its density and porosity indicate that it consists of a loose conglomeration of rubble, making it more susceptible to external influences such as gravitational forces and solar radiation. Unlike Apophis, which has a more compact and dense structure, Bennu is a loose asteroid, as confirmed by data collected by OSIRIS-REx. Studying both Apophis and Bennu plays a crucial role in developing strategies for mitigating the threat of potentially hazardous asteroids. Missions like OSIRIS-REx provide critical data that can be used to develop asteroid deflection technologies. In the event of a real threat, such technologies might include using spacecraft to alter the asteroid's trajectory, as demonstrated by NASA's Double Asteroid Redirection Test DART mission. The comparison between Apophis and Bennu highlights the importance of continuous monitoring and research of near-Earth objects. While the immediate threat from Apophis has been eliminated, ongoing observation and analysis remain vital for ensuring the safety of our planet. Bennu, on the other hand, represents a unique opportunity for direct exploration and understanding of the nature of asteroids, potentially leading to significant scientific and technological breakthroughs. Stay tuned for updates on these and other space objects to stay informed about the latest discoveries and events in the world of astronomy. Your likes and comments help us create more engaging and informative content. Share your thoughts in the comments and stay with us for more cosmic adventures. My perspective on asteroids Apophis and Bennu. Initial calculations indicated that Apophis would come extraordinarily close to our planet in 2029, causing serious concerns among scientists and the public. On the one hand, I find it astonishing that an asteroid of such size, 340 meters across, could approach Earth at such a short distance. This underscores how dynamic and unpredictable our universe is. Thanks to modern technologies and observations, we have been able to refine its orbit and rule out the risk of collision in 2029 and 2036, which demonstrates significant progress in planetary defense. On the other hand, I am concerned that we still cannot completely rule out the possibility of a collision in the distant future. This reminds us of the importance of continuing research and developing technologies to mitigate the threat from potentially hazardous asteroids. Asteroid 101955 Bennu also deeply interests me. Its size and orbit make it no less important an object for study than Apophis. Bennu represents a kind of cosmic laboratory thanks to NASA's OSIRIS-REx mission. This mission has allowed us to collect samples from the asteroid's surface and will return them to Earth in 2023. This is a significant achievement that will open new horizons in our understanding of the composition and structure of asteroids. I am fascinated by how technologies and scientific missions like OSIRIS-REx enable us to directly study such distant and mysterious objects. The samples brought back from Bennu may hold the key to understanding the processes of solar system formation and the origin of life on Earth. They also provide us with crucial data for developing strategies to protect the planet from potential threats. However, the future collision risk posed by Bennu, although unlikely, also underscores the necessity for constant monitoring and the development of asteroid deflection technologies. This once again reminds us of how fragile our planet is and the importance of continued investment in scientific research and space technology. Both asteroids, Apophis and Bennu, are significant objects for astronomical research and planetary defense. They remind us of the importance of being prepared for potential threats from space, while also opening new possibilities for scientific discoveries. These objects highlight that we live in a dynamic and ever-changing universe, and it is our duty to study and protect our planet. I would be happy to hear your opinions on these asteroids. How important do you think such research is for the future of humanity? Share your thoughts in the comments, and don't forget to subscribe to our channel to stay updated on the latest news and discoveries in the world of astronomy.